Energy storage, battery backup, home batteries. We can call them a lot of different things, but it's all the same thing. We're all talking about batteries for the house. And usually these come up, often from a simple question. It comes very often. And it's solar will power my house when the power goes out, right? And unfortunately, the answer is no to that question. That comes from a National Electric Code guideline where for a solar only system, if the power goes out, like the grid goes down, that system has to turn off. It'll automatically turn off, and it's a protection mechanism. Let's say an above ground power line outside gets knocked down by a bad storm, and that line's now laying on the ground. If you had solar that was feeding power back into the electric grid, that could harm a worker for the utility company when they're trying to fix the problem. So again, that electric code guideline requires that these systems turn off, and so it'll automatically turn off and protect folks if they are working on the home. But where it wouldn't turn off is if you had a battery in the house. And so again, we're running into a lot of cases where typically with either bad weather, crazy storms, utilities cutting off the power, there's a lot of different reasons why homeowners are seeing their power shut off, and they're trying to find a reason to stop that. And so they come to us thinking initially that solar is going to solve the problem. We need to help direct them to show that they would need solar plus battery to really solve this issue. So, what is a solar battery? And a solar battery for the house is really just a really big battery pack that goes on the side of the home. It's much like any other device that we use has a battery attached to it, but again, much larger to be able to power a lot of items in the home for a while. And so, what we're doing, again, that battery gets tied into the electrical system on the home. We're using the solar panels now to be able to help charge that battery up. And now we've got stored energy at the home. We're not solely reliant on the solar panels to make electricity during the day. We can have that solar power, be able to charge those batteries, and be able to use that electricity from the battery if it's the middle of the night, or it's a really cloudy day, or again, if there's a power outage. And so this lets you keep your solar power on site more often rather than either use it as it's being produced or feed it back into the grid. Now we've got another option where we can store it on site. So this is an illustration that shows a home with solar panels on top. We can also see a couple Tesla Powerwalls on the side of the home, but with this illustration, we're seeing, the blue lines with solar feeding power into the home, or that green line showing solar feeding power into the batteries, and now showing that battery discharging in the middle of the night to be able to use some of that stored electricity. Another method that we can use those batteries, as shown in the text, is we could leverage that battery storage to be able to feed in power to avoid expensive time of use charges from the utility company. So it's another great reason to be able to have a battery, not just in the off chance that the grid goes down, but now we can use that battery even every day if we wanted to avoid, again, really expensive time of use charges, typically in the afternoon from utility companies, or again, we could use that power at nighttime as well. Another common question comes around the battery chemistry. And so we're always using lithium ion batteries, which again, same sort of technology that we've got in a lot of our devices, our phones, our computers, our AirPods, who knows what. Lots of different devices have lithium ion batteries, and our solar batteries are no exception. This is a great alternative to the more typically used years ago lead acid batteries, similar to car batteries. The big benefit with lithium ion batteries now is the size, the as well the depth of discharge, and so we can get a lot more power out of a smaller package with that lithium ion battery, and have a lot more reserves at the home, and so it's more usable than a big bank of old lead acid batteries that require a lot of maintenance, and you're spilling chemicals and they need to be vented, and it's just a mess. Nobody wants that. So our lithium ion batteries now are maintenance free, easily packaged, and something where you've got a lot of good use out of it. Other common topic that you will likely not need to talk about with a homeowner, but we teach just so our team knows how these things work, and can have a more detailed conversation if need be, but is the method by which these batteries are coupled to the home. And we learned in an earlier module that power is either AC or DC, or alternating current or direct current, right? So we can couple a battery to the home on either side of that equation. And we think back to an earlier example as well, that our solar panels make direct current electricity. That power flows down the side of the house to the inverter box, and that is where that power conversion happens, where the power is converted from DC to AC. So if I'm talking AC coupled or DC coupled, I'm just talking about where is the battery connected. Is it on the DC side, or is it saying it's between the solar panels and the inverter? Or is it the AC side? It's after the inverter. It's after that power has been converted already. So we're, as the screen shows, we're focused on AC coupled systems. And we have a preference for these because DC coupled systems, again, they're between the solar panels and the inverter. So it means they can only be charged during the day when the solar panels are working. And so where that can present an issue is, let's say we were talking about that time of use example earlier. So we've got, during the day, our solar panels make electricity. If I've got it during the evening, I've got a really expensive time of use charge that I want to avoid, and I end up discharging my entire battery charge doing so. If I have a DC coupled battery, that means I have to go all night with zero power in my battery. I've got to wait till the sun comes up the next day for that battery to be able to charge up. So with an AC coupled system, it's after the inverter. It's on the AC side. So I can charge it from my solar. I could charge it from the grid. So the same example, I've got solar making power during the day. I've got an expensive time of use charge. I could discharge my whole battery. I'm not worried because I could charge the battery back up with the grid in the middle of the night. And that way I've got power reserves. If my power went out in the middle of the night, I've got my battery. And I don't have to use all my early morning solar power to just charge that battery back up. So that's one reason why we like AC coupled systems. Another really important reason is to be able to retrofit batteries onto existing solar systems. That is easily doable with an AC coupled system, not with a DC coupled system. So if we think about, we've all seen a lot of solar on roofs. Most of that solar does not have a battery attached to that system. So we get a lot of questions from customers, even existing solar customers, that say, hey, I want battery backup now. We've, in those cases, again, especially want to go with an AC coupled system. It's a lot easier retrofit, and just it makes it more user friendly and certainly cheaper for the homeowner to be able to have battery storage at that point. So with these two crucial points, that's where the only batteries that we've got today are AC coupled, and it's a much better benefit for the homeowner. So another very common question that we get is, as shown, this battery will power the whole house, right? And unfortunately, the answer to that one is also no, but I'll say it depends too. And so our batteries, and we're commonly using the Tesla Powerwall as of this recording, but let's use that Tesla Powerwall in this example. So it is technically a whole home battery. I can have it tied to the whole home, but I need to pick what circuits I want running off of that battery. And so I need to think about, and we can go over in another module, but I need to think about how much power can I push through at one point, and then as well, how much power reserves do I have? And so, if we think of anything else that uses a battery, like my computer, for example, if I run a bunch of programs all at max power, all at once, that's a big electricity draw, right? That's going to want to run down my battery very quickly. And so, big draw, very short battery life. And so we need to think about what are the draws that I can push through this. I also want to think about that battery management. So we also need to look at the specifications of the battery to make sure that there's some items like heavy power draws, like air conditioners, for example, that a single Powerwall can't even turn on a number of different air conditioners commonly found in a home. So, if somebody says, "Oh, I want to run everything, including my air conditioner," we need to ask a lot of questions of any homeowner that's asking about batteries, but especially if someone wants to run air conditioning, we need to look at more technical specifications to make sure what all are you trying to run and for how long. We can make a calculation to figure out what is feasible. What would that look like? But generally, it's a comparison of, I want to be able to run some things off my battery, but I also don't want to spend a ton of money on batteries. So if I start to think about, hey, if my power goes out, maybe it's storming, maybe it's a more critical situation. I don't know that I need air conditioning. I don't know that I need to buy another whole battery just to run the AC in those cases where the power goes down. So I might think of more of an emergency type of situation where power's out, my battery's going to kick on automatically. I probably just need a few circuits, lights in the kitchen, right? The family's huddled around the kitchen if they're doing things or trying to charge things. I might want a fan in the living room, right? If I'm in a household that has sensitive medical equipment, I want to make sure all that's running, right? So a number of questions that we ask about if somebody wants battery backup power, what all do we want to run? How often do we want to run it? How long do we want to run it? Is there any, again, sensitive medical equipment that we need to pay attention to? So we look at all these things to be able to design the right system, or even have more of a consultative discussion about, I know you want that, not technologically feasible today, and for the cost that you want to invest in this, maybe we'll focus on one battery, and again, you do those kitchen circuits, the fan, etc., right? So no reason to shy away from batteries. It's a few basic questions, but something that, again, we like to go through to make sure our customers are satisfied, they get what they're expecting with it, and ultimately they're happy with the investment that they're making. So we show another visual example here on that AC coupled system, but it starts to show more components, and now starts to turn into review on some of the topics we talked about. So the obvious first point is number one, those are our solar panels on the roof. Then that power feeds down into box number two, which is our inverter. Now I know anything after that inverter is on the AC side. So even though the text shows it, I could look at the diagram and see this is an AC coupled system. Box 3 is our critical loads panel. So that would be, again, the aptly named critical loads. Like those are those loads that we have to have running in an emergency. That runs through there. And then we can feed into batteries, the main breaker panel, and then the house accordingly. So we set up all the electrical connections, but it's driven by those questions that we ask to be able to make sure that, yes, the circuits that are in that critical loads panel are what the customer wants and is hoping to be able to use when the grid goes down. So here's another example from Tesla that shows different scenarios. Like here we're using the Powerwall to charge a car to be able to run the house. And it's showing the grid being down as well. We're running completely off that battery at that point. So here we could see this grid outage. I've got the home powered by the battery. Now we've shifted back to solar, charging that battery back up, and the cycle can repeat itself. So this is the big benefit, if it wasn't already obvious, that if we're doing solar plus battery, we can make power from our solar panels, charge up our battery, so we can have power during the day, battery at nighttime, and have days and days and days of power in the house to be comfortable, even if the grid is down. So very user-friendly and more importantly, very comfortable for a homeowner to get that comfort aspect in their home here. So benefits, starting to summarize. So, we talked about, again, having a battery. We've got electricity even when the sun goes down. So we're storing that solar power locally. We're not having to feed it back into the grid. And we've got that electricity now on tap in our battery. We can use it at night. We can use it to avoid peak time of use charges, and as well demand charges where applicable. A big reason why people ask, but again, not as often of a use case where people want batteries to be able to give relief from power outages. But power doesn't go out every day for most of us, right? And so it's a good thing to have, but where most folks will benefit from having a battery on the day-to-day basis is, again, to be able to have that electricity after the sun goes down and have that stored on site. So very helpful to have a battery, not just for storing for power outages, but to be able to leverage that battery storage for various other purposes. Again, avoiding those peak time charges and keeping more of the power produced on site. So peak demand. So again, what this is, we're showing a graph here, but what that's doing is modeling energy usage at different times a day. And so we could see at 12 a.m., midnight, people are asleep, right? There's not much being run. Maybe you've got your clocks, the fridge running, things like that, but lower load items. But you get up, you start to turn lights on, you start to use appliances, that usage goes up. You leave for work, things get turned off, right? Usage goes down. Get back home, cooking, getting the kids ready for bed, all that sort of thing. That's when we typically see our highest usage, in the late afternoon to evening time. Pretty common across all utilities across the United States. Obviously, different areas with different weather will have different curves, but for most places, that biggest demand is in that evening time, kind of dinner, bedtime rush that we're all used to, right? So there are different utilities that not only do they bill you for how much power you use, but they'll also have demand charges that they can bill you based on what your peak usage is. And so, what we're looking at is, on this text here, we're talking about the demand charge, and what they're doing is pulling across a month's time, across that billing period. A utility company is metering all your usage. They could see how much you're using, but they can also see how much you're using at any given point. And so, depending on the utility, they'll look at the single highest demand load across either a 15 or 30 minute window during the week. And that's going to generate your demand charge for the entire month. So if we think this through, where this turns into an issue is, for people that pay attention, they can help manage their peak demand pretty well, because that cost can really start to spiral out of control. But for those of us with kids that can't always control everything that's going on, this could start to get a little scary, right? So let's say one of your children comes home, they turn on the air conditioning, the hot tub, everything in the house. That's a lot of electricity usage, right? That's going to be a very large peak demand. And even as something as little as a 15-minute period, it can be the basis by which you're charged over an entire monthly billing period. So it can be painful in a very short order, and something that not every utility has this plan, but for those that do, it can be, again, an uncomfortable exercise in trying to keep that peak usage down. Where we could start to see this get really uncomfortable is, let's say, we've got retired folks, fixed income. They're home a lot. They're trying to be comfortable. They want to use their air conditioning, but sometimes these peak charges can really negatively impact folks on a fixed income. And unfortunately, we've seen cases where people have to not run the air conditioning at times, even though they're uncomfortable. Maybe they can't afford the electric bill. And so that's where we can help with solar, especially with batteries too, to try to help reduce that peak demand and give some relief on that front. But just again, another complex topic that you don't always need to get into the nitty gritty on the explanation, but we like our team to be able to know how this works, so that way if it does come up, you can explain it effectively. And we could see some different examples, like how one would show on an electric bill. We just pulled a quick example here, and you could see how that could vary throughout the month depending on what your usage curves looks like.